This video will describe chapter 4.5, scatter plots and lines of fit. So let's start with the idea of scatter plots. And so there are three different types of correlation in scatter plot. The first one is a positive correlation, and what this means is that as x, which is this value, increases, y increases, and as x decreases, y decreases. So the idea is that x and y are moving together. Okay? Negative correlation is as x increases, y decreases, or as x decreases, y increases. So negative correlation simply means that x and y are moving in opposite directions. Right? So as x goes up, y goes down. As x goes down, y goes up. Whereas these, when x goes up, y goes up. When x goes down, y goes down. And then no correlation means that there is no relationship between x and y. We cannot predict y based on what's happening with x. So a very popular example for positive correlation is studying in grades. And the more time you spend studying, the better your test score is. Right? And so as x goes up, y goes up. And the less time you spend studying, the lower your test score is. Now, as we know, that's not 100% true, and doesn't mean that it happens every single time, but it does help us to predict, and that's what these correlations are used for. But the biggest mistake that people make is they think that positive has something to do with the outcome. So for example, a higher test score is a positive thing, that's a good thing. But positive correlation simply describes this relationship. So an example of a negative outcome that is a positive correlation might be the idea of smoking cigarettes. And the more cigarettes somebody smokes, the more likely they are to get lung cancer. So as they smoke more cigarettes, the incidence or the likelihood of lung cancer increases. As x goes up, y goes up. But as we know, lung cancer obviously is not a positive outcome. However, cigarettes and lung cancer have a positive correlation. Again, same thing with negative. As x goes up, y goes down. As x goes down, y goes up. Doesn't necessarily mean that this needs to be a negative outcome. So for example, the more people who wear seatbelts, the fewer deaths we have in car accidents. And then the fewer people who are wearing seatbelts, the more deaths we would have in car accidents. And so that's obviously people's lives being saved is clearly a positive outcome. However, seatbelts and deaths in car accidents have a negative correlation. Again, the no correlation would be two variables that have no relationship. So for example, the number of letters in your first name and your height. And so, you know, this would, if it was positive, the more letters in your first name, the taller you'd be. The fewer letters in your first name, the shorter you'd be. If it were negative, the more letters you had in your first name, the shorter you would be. The fewer letters you had in your first name, the taller you'd be. And I'm assuming, as you could probably guess, if you were to do this study, you would find that there is no correlation between the number of letters in your first name and your height. All right, so let's talk about how we use this now. So what we're going to do is take a look at this table. You do not need to copy this down. I actually have it on a scatter plot for us already, but this is years since 1988 and the vertical drop. And we're talking about roller coasters here. So this is 1 year after 1988, so 1989, this would be 3 years, so you're looking at 1991, and so on. What we want to try to do is use this information to predict 25 years after 1988, so in other words, the year 2013, what would the vertical drop of a roller coaster be using this data? So the first thing that we need to do, put this off to the side for a second, is we need to create a scatter plot. So I've kind of created a scatter plot. I'm going to put it close, hopefully, so that you can see. And so this is years since 1988 down here on the x-axis, and then this y-axis is the vertical drop. And you can see I've taken, I'll come back to this in a second, I've taken these points. So this is my x, and this is my y, and I've put those points on a plot, which is this. So these are just the plots of that data. Now the idea is from here, what I want to do is I want to create a line that kind of goes through here that basically describes this graph. So in other words, what I could do is after I've drawn this line, I could pull all the dots off, and that line kind of tells my story of what's going on with this graph. And we also could use this line then to predict. So I'm going to show you the line that I've drawn. Keep in mind that there is some variance in this line. You can kind of pick and choose where you want to go. And if you look closely, you can see underneath the line I drew, I actually have another line that I erased because I decided that I didn't like that line. I didn't think that line actually told the story. And so one mistake that people often make is that they try to put, let me grab a board so I can hold this steady. Probably making you dizzy the way that I'm shaking that thing around. So the one mistake people make is they often try to put the same number of points above the line as they put below the line. And that doesn't necessarily have to happen. And so in this example, I have 1, 2, 3, 4, 5 above the line. 1, 2, 3, 4, 5, and then I have 1, 2, 3 beneath the line, and then I have this point that is right on the line. You do not have to have one, the line does not have to go through one of your points either. In this particular example, it worked out that way because of the way that I drew the line, but it doesn't have to work out that way. So keep in mind that this point, the fact that it goes through that point is somewhat coincidental. That's not something that has to happen every time. Okay, and so notice that part of the reason why I ended up moving my line up, as you can see, I kind of have this erased line beneath it. Part of the reason I moved my line up is because this point I felt like we should be dragging the line a little bit higher than where I had drawn it the first time. Okay, and so it's very close to these 2 points. It's closer to these 2 points than it is to these 2 points. You can see it kind of goes through this point, and then it has these 2 above it. This one's just beneath it, and then this one I felt like was kind of dragging it up a little more than I had given it credit for the first time. And so now what I'm going to do is I'm going to use this line. Now, keep in mind, now I want you to kind of, in your mind, pull those black points off. I'm going to use a red now, and what I want to do is look for perfect points that I can find. So for example, this point, which is at 4, 175, is where that line goes through a point that I can use. So that would be a point that now I can think about. There's another one here at 2, 150, right? That's a point I could use. You could see one over here, which is at, what's that, 15, 325. And then if you wanted to keep going, you could use this point, you could use this point, you could use this point. So what you can see is I'm kind of going through, and I'm just on this line. Let me move it closer so you can see. I'm kind of going through and I'm looking for where it goes straight through one of these squares. So for example, notice that like at 7, it's here, right? It's not going straight through one of those lines. So I don't know exactly what the y value is there. I mean, I could guess what it is approximately, but I don't know exactly what it is. Whereas here, it goes straight through. So I know this is 4 and I know that this is 175. So I can use that value much better than I could use something like even right here, which is very close. If you can see, it's very close to this line, to this point, but it's not quite on it. So that's what I'm looking for now. So basically at this point, and I know it's tough to see the difference between the red and the black, but I'm essentially pulling the black dots off of this graph now, and I'm only going to use the red. And in fact, to keep my numbers small, I'm going to use these 2 points because I need to find the equation of this line. Okay, and so what I'm going to do is I'm going to take those first 2 points, which I figured out to be 2, 150 and 4, 175. So again, if you look at the graph, I'm using these first 2. This one is at 2, 150, and this one is at 4, 175. Okay, and so I'm going to use those 2 points, and I need to find the slope of this line. So I'm going to use x1, y1, x2, y2. And so this is 175 minus 150 over 4 minus 2. This equals 25 over 2. Now, this is where a lot of people end up simplifying, and they try to make this into 13.5, and I want you to try to hesitate and not necessarily make this into 13.5 just yet. Okay, and so if we could, all right, we're going to keep this as 25 over 2. So my slope is now m equals 25 over 2. Now there are 2 ways that I can then figure out the equation of this line. One is to substitute these points in, which is probably going to be the easiest way, and the other would be to use y equals mx plus b. So we can kind of go through ways if you want. So the first way let's put this here, is going to be to go y minus y1 equals m times x minus x1. And for this particular example, I'm going to use these 2 points. So I'm going to use 2 and 150. So this is going to be y minus 150 equals 25 over 2 times x minus 2. So this becomes y minus 150 equals, when I distribute this, it's 25 over 2 x, and then 25 over 2 times negative 2 is the same as negative 50 over 2, which is the same as negative 25. Okay, then from there what I need to do is add 150 to both sides. This will cancel out. I've got y equals 25 over 2x plus 125. Okay, now that's one way that I could solve this. The other way would be for me to take y equals mx plus b. Again, using that same point, 2 and 150, I would substitute 150 here equals 25 over 2 times 2 plus b. Okay, this is going to become 150 equals 25 plus b. Subtract 25 from both sides. And I'm left with b equals 125. Now, from there, I know that y equals, what's my m? 25 over 2x plus, what's my b? 125. So either way, I get 25. Let's write this so it's actually legible, sorry. So I get y equals 25 over 2, which is my m, x plus my b, which is 125. So you have that equation, and you have this equation, which should be and are identical. So no matter how you get it, there is my equation. Now keep in mind that what our question was to predict roller coasters 25 years after 1988. So what I need to do is I would then need to take this equation, and I'm going to have to substitute a 25 in there. And now at this point is when I'm probably going to need to change it to a decimal. So I'm going to grab the calculator because I'm probably going to need this. And so what we're going to end up doing is taking 25 and we are going to substitute it in for x. So let's take this board. So I'm going to go using my equation y equals 25 over 2x plus 125. I'm going to take, since I'm going 25 years after 1988, this is y equals 25 over 2 times 25 plus 125. 25, so this, let's go here, so y is going to be 625 over 2 plus 125. So the easiest thing at this point is probably to take this and make this into a decimal. Since I am looking, we are talking about feet, which is typically spoken of in decimals and not in fractions. I got 312.5 plus 125. And so finally my answer is going to be 437.5. Now, keep in mind that my final answer, y equals 437.5, that is feet. So we're saying that in 25 years after 1988, in the year 2013, the roller coaster is going to drop vertical drop of 437.5 feet. And if we come back to this graph, if we were to take this out to 25, we should, when we come up here, be at, I mean, if this is 425, we should be somewhere in this range. Right? And so that's the idea, is that as I come out here, this should help me predict where that line is going to be. All All right. So this is how we are using scatter plots. Now keep in mind the difference between positive, negative, and no correlation. And then keep in mind what a line of fit is. You're going to take that scatter plot. Sometimes you have to create the scatter plot. Sometimes they will give it to you. You're then going to draw that line. Then we need to find the slope and equation of that line so we can use it to predict for the future. Please make sure you answer the questions at the bottom of the page. Thanks for watching the video, and I'll see you in class.